Now let us begin with the derivation of the odd and even identities. So we'll start with the cosine of the difference of two angles, which, just to remind you, was cosine of beta minus alpha was cosine of alpha cosine of beta plus sine of alpha sine of beta. If we make the substitution and take beta to be 0, then when we plug in, we get cosine of 0 minus alpha is cosine of alpha cosine of 0 plus sine of alpha sine of 0. But cosine of 0 is going to be 1, sine of 0 is going to be 0, which leads us to cosine of negative alpha is equal to cosine of alpha. And so we see that cosine is an even function. So if we then remember the reciprocal identity that the secant of theta is going to be 1 over cosine, then we can derive that the secant of negative alpha is going to be 1 over the cosine of negative alpha, but cosine is even, so this is just the cosine of alpha, but 1 over the cosine of alpha is secant of alpha. And so we see that secant is also an even function. So we have the two of our odd and even identities, that cosine is even and secant is even. For the remaining identities, we go back to the sine of the sum of the two angles, being sine of beta cosine of alpha plus cosine of beta sine of alpha. And now we do kind of an interesting manipulation. If we start with the sine of negative theta, then we can add something and subtract something so that everything stays balanced. So this is the sine of minus pi over 2 plus pi over 2 minus theta. So now if we group these in a particular way, so we'll group negative pi over 2 together, and then we'll also group pi over 2 minus theta together. So minus pi over 2 will take the role of beta, pi over 2 minus theta will take the role of alpha, and so if we use our trig identity from up here, we'll see that this gives us sine of negative pi over 2 times cosine of pi over 2 minus theta plus cosine of negative pi over 2 times the sine of pi over 2 minus theta. But then we bring that back to negative cosine of pi over 2 minus theta, and then using our cofunction identity, the cosine of pi over 2 minus theta is the sine of theta, and we end up with another one of our odd and even identities, that the sine of negative theta is negative the sine of theta. So sine is an odd function. Doing the same thing as we did for secant, we can remember that the cosecant of negative theta is going to be 1 over the sine of negative theta. But we just found out that sine is an odd function, so the sine of negative theta is negative the sine of theta. So we can take that negative off to the side, and we have 1 over sine of theta, but 1 over sine of theta is cosecant of theta. So we see that cosecant is also an odd function. Coming over to the quotient identities, we've got the tangent of negative theta is equal to the sine of negative theta over the cosine of negative theta. But using the fact that sine is odd, we can take that negative to the outside, so we've got negative the sine of theta in the numerator. Cosine is even, so the cosine of negative theta is just cosine of theta. And so the negative from the numerator we'll put to the outside and just leave us with sine of theta over cosine of theta. But back to our quotient identity, that is tangent of theta. We can do the same thing for cotangent. Cotangent of negative theta is cosine of negative theta over sine of negative theta. Cosine is even, so we have cosine of theta over negative sine of theta because sine is odd. Take the negative to the side, we have cosine of theta over sine of theta, which ends up giving us a negative cotangent of theta. So both tangent and cotangent are odd functions.